So are you people replying, or am I not able to see the replies? So yes, Jyoti, what should be the right answer for the first question? So we'll discuss the first question, and then rest of the two you have to try yourself, and again tomorrow we'll see what is the right answer. Yes, Ashrita, Gayatri. So no one is replying there. So in that case, I'll have to ask to unmute you, and then you have to tell me the answer. Yes, Jyoti, are you there? So now, if you are done, so Gayatri, did you get the answer? What should be the right answer among these? Which one has the highest mass? So the options are 1 gram atom of carbon, half mole of CH4, 10 ml of water, and 3.011 into 10 raised to the power 23 atoms of oxygen. So now your first option is 1 gram atom. So when someone says 1 gram atom, that means 1 mole of carbon. So what will be the mass of 1 mole of carbon? It will be 12 grams. Now, similarly, so it will be 12 grams. Correct? Now, here it says half mole of CH4. So what will be the molar mass for CH4? So the molar mass for CH4 will be, you have to reply in the chat, what will be the molar mass for CH4? So I'm looking at the chat in my phone. So you have to reply. I am waiting for your replies. So what will be the molar mass for CH4? This is very easy. You should be able to calculate the molar mass of CH4. So for carbon, it will be 12, and for hydrogen, it is 4 into 1, right? So 12 plus 4, how much you will get? You will get 16 gram per mole. So how many moles do we have? We have half mole. So the mass of 1 mole is 16. So the mass of half mole will be 8 grams, right? Now here it says 10 ml of water, correct? So here volume is given, right? 10 ml of water, and as you know that the density of water is 1. So here what we can say is that the volume and mass would be same. So how can I write it? I can write it as 10 grams. So for ml, I can just, for water, this you can do for water because the density is 1. So as you know, density is equals to mass upon volume. So whatever volume we have, it will be same as the mass because the value of density is 1. So here for water, we will have 10 grams. Whereas it is saying 3.011 into 10 raised to the power 23 atoms of oxygen. So what does it means? So 6. So we will do this one by using the formula. You are given the number of particles, right? So what will be the number of moles? So you are given 3.011 into 10 raised to the power 23 divided by 6.023 into 10 raised to the power 23. So you'll get half moles, that is 0.5 moles. And the mass of 1 mole of oxygen is 16 grams. So what will be the mass of this much oxygen, which is 0.5 mole of oxygen? Yes, what will be the mass for 0.5 moles of oxygen? So what will be the answer for 0.5 moles of oxygen? So one atom of oxygen has the mass of 16 grams, so it will be 8 grams. So what should be the right answer? Now the answer is in front of you. You have to quickly tick the right answer. What should be the right answer? Yes. For oxygen, it will be 8 grams. Yes, so the right answer is option A. Option A is correct, that 1 gram per atom of carbon has the highest mass. As you can see here, that it is 12 grams. Now you have to try this problem, and here this is 5.6. This is not 56, this is 5.6 liters of oxygen, as NTP is equivalent to. So you would see two kinds of condition. One is STP and one is NTP, right? So STP is standard temperature and pressure. So STP is standard temperature and pressure. So here pressure will be 1 atmosphere and temperature will be 273 Kelvin, whereas NTP will be normal temperature and pressure, and normal temperature is taken as 25 degree Celsius, and you can then convert it into Kelvin. So NTP is normal temperature and pressure and STP is standard temperature and pressure. So here pressure in both the cases will be 1 atmosphere, and your temperature, for standard temperature we will have 0 degree Celsius. For normal temperature we'll have 25 degree Celsius, or between 25 to 27. So I hope you can do these problems. Now there is one other important thing that we should understand is that whenever somebody says that you are given 1 mole of water, for example, somebody says that you are given 1 mole of water. So what does it mean? That we have 1 mole of water molecules. What do we have? How many water molecules do we have in this? We have 1 mole of water molecules, right? So now if somebody asks you what is the mole of hydrogen atom here, so quickly tell me what will be the moles of hydrogen atom in 1 mole of water. What will be the number of moles of hydrogen atom? So from here, what you can see is that 1 molecule of water has 2 hydrogen atoms, right? What we can say is that 1 molecule has 2 hydrogen atoms, right? Similarly, I can say that 1 mole will have 2 moles of H atom. So what is the number of moles of H atom? So we will have 2 moles of H atom in 1 mole of water. And what about the number of moles of oxygen atom? I am talking about atoms. So don't be confused between molecule and atom. Just read the things very carefully. Read the question very carefully. What are they asking? Okay. So now if I ask you about what is the moles of oxygen atom in 1 mole of water, so it will be 1 mole. Similarly, you will have to do for 1 mole of methane. So in 1 mole of methane, what is the mole of CH4 molecules? It will be 1 mole. What is the number of moles of carbon atom? And what is the number of moles of H atom? Yes, quickly answer for the number of moles of C atom. So carbon will be 1 mole. And what about hydrogen? What about hydrogen? Yes, Ashrita. Yes, hydrogen will be 4 moles. So if you are given any molecule, they can ask you anything. It's not just that they'll ask you the conversion. Sometimes you may get the questions related to what is the number of moles of atom in these many grams of a compound. So yes, you should be able to know that. Whenever you are looking at any compound or any molecule, then whatever is the atomicity of the particular element, that will be the number of moles. Now, the next topic that we have to learn about is how do I calculate the percentage of particular element in any compound. So let's begin with water only. So let's suppose I ask you what is the percentage of hydrogen here. So what you have to do is you have to write whatever is the total mass of that element, and then you have to divide it by the molar mass of the compound or the molecule into 100, and that's how you can find out the percentage of the particular element. So it's not just for hydrogen. So here, this is the formula for percentage of element, right? What you have to do is that the total mass of that element in that particular compound divided by the molar mass of the compound into 100. So let's suppose if I have water here. So let's do for water. So for water, what will be the percentage of hydrogen? So what do we have? We have 2 moles of hydrogen, right? So what will be the mass for 2 moles of hydrogen? It will be 2 grams. And what is the molar mass of water? It is 18. And then you multiply it by 100 and then you will get 11.11. Similarly, what will be the percentage of oxygen? It will be 16 divided by 18 into 100, which is equals to 88.88%. So that's how you can find out the percentage of element. If this is clear to you, type yes and then we will move ahead. And by that time, you can try for methane also. So for methane, what you have to do is you have to percentage of carbon. So how much it will be? So the mass of carbon is 12 and the total mass of methane molecule is 16. So 12 by 16 into 100. Similarly, you can find out what is the percentage of hydrogen. So in the same way, what is the weight of hydrogen here? 4 grams divided by 16 into 100. So how much you will get? These division I hope you can do. So here we'll get 75% and 25%. In the same way, you have to do for all the compounds that may be given to you. For example, you could be given any compound. So your homework is you have to calculate the percentage of elements, or we say mass percent of elements for C2H5OH, which is ethanol. So this is your homework, that you have to calculate the mass percentage of elements for ethanol, which is C2H5OH. I hope you will be able to do it. So if the percentage of element, this topic is clear to you, type yes, and then we will move with the empirical and the molecular formula. So once we know how to calculate the percentage of elements, then obviously we can have the question based on the percentage of elements, and from there we will have to find out the empirical and the molecular formula. Yes, if this is clear to you, type yes, and if there is any doubt, you can ask me. So we will understand about the empirical and the molecular formula through an example, through a question, or we say a numerical. So let's suppose if you have a numerical which says a compound contains 40% carbon, 6.67% hydrogen, and remaining is oxygen. And if the molar mass of compound is 120 gram per mole, then determine its molecular formula and the empirical formula. MF is molecular formula and EF is empirical formula. So this is molecular formula and this is empirical formula. So these are the kind of numericals that you will find related to empirical and the molecular formula. So here the first thing that is important for us to know is what is the empirical and the molecular formula. So empirical formula is the simplest ratio of atoms of all elements present in a compound. whereas the molecular formula is the actual number of atoms of all elements present in a compound. So empirical is the simplest ratio. For example, let's suppose if you have glucose, which is C6H12O6, right? Now if I write this formula in the simplest ratio, then I'll divide all of the atoms with 6, right? So what I'll get CH2O, right? What I'll get CH2O. So this is empirical formula and this is the molecular formula. So here we have the empirical formula and this is the molecular formula. And then from here, what we have to do is we have to find out the molar mass, and from here also we have to find out the empirical mass. So here what we will get 180 gram per mole. Similarly, we have to find out the empirical mass. And then, so if I find out the empirical mass, how much we will get? So yes, what will be the empirical mass for CH2O? So this will be 12 plus 2 plus 16. So how much it will be? Yes, it will be 30. So then we can find out the value of N. What is N? N is the number that I'll multiply the empirical formula with so as to get the molecular formula. So here how we can find out the value of N? So here we have to divide the molar mass with that of the empirical mass. So just do the division. It's a very simple process, but you should know how we are doing it. So 180 divided by 30. So yes, you have got 6, right? So you can see here, right? If let's suppose it was not known to me that what is the molecular formula, and in the numerical what is given to me is the just the molar mass, right? And the percentage composition. That is how this question is. What you are given in this numerical is the percentage of elements, and then you were given the molar mass, and then they were asking about what is the molecular formula and the empirical formula. So yes, once you know the value of N, then from there you can find multiply the empirical formula with that of with this N, and then that's how you will get the molecular formula. So this is the process that you have to follow. Now the one other question that you should have is, ma'am, how can I find out the empirical formula from the percentage? Yes, we can find out the empirical formula by the percentage by following a certain process. So here I'll show you how to handle these numericals, and then you can do it for all the numericals that will be of the same kind. So what you have to do is, first of all, you have to make a table and write the element. What you have to do, you have to write the element, and then you have to write their percentage. So here the elements that I have is carbon, hydrogen, and oxygen. And what is the percentages here? So the percentage of carbon is 40, the percentage of hydrogen is 6.67. And now once I add both of these and subtract it from 100, then obviously I'll get the percentage of oxygen. How? Even though in the question they didn't give me the percentage of oxygen, but what it is saying that the compound contains carbon, hydrogen, and oxygen. So once you know what is the percentage of carbon and hydrogen, then obviously we can find out what is the percentage of oxygen. So here the percentage of oxygen that we will get is 53.33. Correct? Now, in the next step, what we have to do is we have to find out the moles. So this percentage now you have to treat as grams, because we are talking in the terms of percentage. So it is this part in 100 parts. So here what we will assume is that the compound is 100 grams. So in that In the percentages for 100, in that 100 parts we have 40 parts of carbon, correct? So now what we will do is 40, then we will divide it by the molar mass of carbon. Similarly we will do for this. So for molar mass of hydrogen is 1, and similarly we will do for this. So molar mass of oxygen is 16. You have to follow the same procedure for all the numericals. Now after this, once you calculate what's this ratio, so I'll write the values here. So what you will get is 3.33, so this will be 6.67, and again for this you will get 3.33. Now what you have to do is you have to divide these moles by the lowest value. What you have to do? You have to divide it by the lowest value. So 3.33. So among all these three, which is the lowest value? Yes, I can see that 3.33 is the lowest value. So I'll get 6.67 divided by 3.33. So you'll get 2. Then 3.33 divided by 3.33. I'll get 1. So from here, you have got the integer for this, that is 1, 2 and 1, and this is the number of these atoms, and that's how I'll get the empirical formula. So the empirical formula for this will be, so empirical formula for this will be, how many atoms of carbon we have? 1, and then we have hydrogen, and then we have oxygen. So we will have CH2O. So this is the empirical formula. Now what you have to do is you have to find out the empirical mass, right? So what will be the empirical mass? So you have 12 plus 2 plus 16. So what you'll get? You'll get 30, right? What are you going to get? You will get 30 gram per mole. Now here, now again, let's come to the question. So do we know what is the molar mass? Yes, we know what is the molar mass, or in other words, we can say we know what is the molecular mass. So to find out this, so here I have the molar mass, which is 120 gram per mole. What it is? 120 gram per mole. So from here, I'll find out the value of N, which is 120 divided by 30, that is equals to 4. So from here, what I have to do is multiply this by 4, and in that case, I'll get the molecular formula, which is C4H8O2. So this is how we will find out the molecular formula and the empirical formula for the compound if I know what is the percentage of the particular elements in that compound. If this is clear to you, type yes, and then we will move ahead. Yes. Okay, Ashrita, I have understood. So look very carefully. If you have just see here for a minute, understand everything, absorb everything, and then we will move ahead. Now, there is one other thing that will sometimes you'll not get these numbers. You'll get numbers like 2.5 or something like that. So the first thing that you have to do is you have to multiply them with a suitable number so that you get an integer value. So those kind of numericals we'll discuss when we are discussing the problems. But the procedure and everything, this is the standard procedure which we have to follow to find out the empirical formula if we have the percentage composition of a particular compound. And then there can be lot of variety of numericals which we will discuss in when we are discussing about the problems. Like instead of giving you like this, they can give you mass percent, and there are many other ways in which they will give you the problem, but the procedure remains the same. That is, first, if you know the percentage, find out the moles, divide the moles with the lowest value, and then find out the integer, then find out the integer value. From there, you will get the empirical formula, and then obviously in the numerical you will be given the molar mass divided by that, and then that way eventually you will find out the molecular formula. You have to follow the same procedure. Yes, Gayatri, did you understand this? Ashrita have understood this. What about Gayatri? Is this clear to you how we have to find out the molecular and the empirical formula? So if all these things are clear to you, now we will move on to what is, we will learn about stoichiometry. What we will learn about? We will learn about the stoichiometry, which again is a very important topic, because it's not that we will be using it here in this numerical. We will be using this concept at many stages when we are learning chemistry. So this topic is very, very important. So now the first thing is, what is stoichiometry about? So when you see this word, that is metry, so it is related to measurement. It is related to measurement. And when you say stoichio, then stoichiometry means it is the measurement of elements. It is the measurement of elements. Right? Now, how we are you going to use the mole concept so as to know what is the moles of the product or the reactant that will be required, or what is the moles of the product that will be formed, so that we will understand with an example. So here we will see the reaction of calcium carbonate with that of HCl. So in stoichiometry, what are we going to learn? We will learn, right, how and what is the amount of elements, or what is the amount of particular compound that will be formed in the reaction, or what is the amount of reactant that I must be taking so as to get the particular yield or particular weight. Because now you know everything about moles, you know what mole is, you know how do we convert mass to moles, mole to mass, number of particles, and also you know how do we do the conversion from volume to mass, mass to volume, volume to particles, and particles to mass. So all those information we will be using to know how much weight of reactant I must take so as to get the desired product. Or in that case, if I have a balanced equation, how is it going to help me to know what is the number of moles that will be formed in a particular reaction? So in our next class, we will be learning about the stoichiometry, and then we will see how we are going to know about the stoichiometry of the particular reaction in terms of moles, in terms of molecules, in terms of volume. So this is all for this class. If there is any doubt, you can ask, and then you can continue with the next class. Yes, sir.
Thank you, ma'am.
Yes, sir. Okay, sir. Okay, students, see you in next class.
Right. Hello, students. Hello, everyone. All right, let's get started. So, are you all there? So, students, there are Rakshit is here, Harika is here, Ashita is here, Gayatri is here, Jyoti is here, and some student by name Samsung. All right. Look at this. I'll quickly write sine of x plus pi by 2 x minus pi by 2. You have to quickly tell me from graph, plot the graph and tell me whether it's cos, minus sine or. Alright. This is my sine. This is my cos. Minus sine. Minus cos x. Alright. I'll quickly tell you sine of x plus pi by 2. Tell me what it is. It should be one of these. Sine of x plus pi by 2. I'll write down what is f of x plus a. I move it towards left. F of x minus a. I move it towards right. F of x plus 8 upward. F of x minus a downward. Minus f of x about x-axis. F of minus x about y-axis. All right. Now quickly tell me sine of x plus pi by 2. Quick. Let's have only 1 minute for this one. And the minute starts now. Sine of x plus pi by 2. What it is? Sine of x plus pi by 2. That is, first one, I shift it towards left by pi by 2, I get cos x. So sine of x plus pi by 2 is cos x. Sine of x minus pi by 2. Sine of x minus pi by 2. I shift this sine x towards right, I get minus cos x. Students, are you all there? All right, good. Hmm. All right. Now we have got all these sine of x minus pi by 2. What it is? Sine of x. I shift it towards right by pi by 2. I get minus cos. Sine of x plus pi by 2. I shift sine x towards left by pi by 2. I get cos. Cos x. Cos of x minus pi by 2. Cos x minus pi by 2. I shift it towards right by pi by 2. So I get sin x. Cos x plus pi by 2. I shift this cos towards left by pi by 2. What I get is this graph minus sin x. Cos of x minus pi. Are you all following, students? Cos of x minus pi. This is pi by 2 and this is pi. This is pi by 2 minus pi. So I shift it towards right by pi. I get minus cos x. So such transformations you can quickly do by, if you just know these 4 graphs, you can quickly do all these transformations. Same thing goes with tan and cot. If you just know tan and cot, you can do the transformations very quickly. Now, let's move on to differentiation. What we have done yesterday at the end, this was just quick revision of what I intend you to master it. But now let's move on to differentiation, what we have done yesterday at the end of the session. What we have seen yesterday is mechanical differentiation from mechanical and geometrical perspective. From mechanical and geometrical perspective, we have seen sorry. All right, we have seen differentiation from mechanical and geometrical perspective. And this is what we are bothered about in physics. Physics lo manam mechanical applications and geometrical applications chustamu. Pure mathematical aspect is seen in mathematics class, which is not required for us right now. All right. So what we have seen yesterday, half gt square curve తీసుకుంటే నాకు slope at point t gave me velocity. So derivative of st curve gave me velocity, which is vt. V versus t gave me gt. So derivative of half gt square is what? Half g is out. Derivative of t square is 2t. That's what you have seen yesterday. So 2 gets cancelled out. I get gt, which is nothing but velocity. That means mechanical perspective says the derivative of displacement gave me velocity, and further differentiation gave me acceleration. So derivative of this one. What is derivative of this one? Nothing but the slope. That's what you have seen. Geometrically, derivative implies slope of the curve, of any ram curve. Slope of the curve gives me a derivative of the curve, derivative of a function gives me slope of the function at that point. So if I have dy dx at x is equal to x naught, this gives me slope at x is equal to x naught. That's what you have seen geometrically. And mechanically, it says derivative of displacement gives me velocity, derivative of velocity gives me acceleration. We will come back to this when we start kinematics. Don't worry about it. We'll come back to this mechanical perspective again when we start kinematics. But right now, you have to understand from your 9th class knowledge that displacement is half gt square, velocity is gt, and acceleration is g. Yesterday, we have seen at the end of the session that derivative of displacement gave me velocity and derivative of velocity gave me acceleration. So what is derivative of velocity time graph? Slope of the vt graph. Y is equal to mx formula undi. Y is equal to mx formula undante. What is m here? Slope of the graph is, slope of the line is, straight line is g. So slope of this vt graph is acceleration. That's what you have seen yesterday at the end of the session. Now, let's quickly do some formulae in differentiation. And the formulas are, if f of x is this, f dash x is this. For x power n, I've got nx power n minus 1. All right. For e power x, or let's say trigonometric functions, sin x, derivative is cos x. I can derive this using first principle of differentiation, using first principles as well. But I'm not going to derive all these things. We will derive sometimes whenever they are required. I'll derive it whenever required in a problem. But right now, we'll go with the formulae. And in fact, mostly will not require the derivation. There are few derivations which are required. We'll do it. X power n gives me nx power n minus 1. Derivative of x power n is nx power n minus 1. Sin x is cos x. Cos x is minus sin x. Tan x is secant square x. E power x is e power x. Ln x natural log is 1 by x. All right, these would be sufficient as of now. And derivative of a constant. What is derivative? It looks at the change in the function as you change the independent variable. X change cheste, x to delta x change cheste, delta y ela change avutundi. For a constant, even if I change x, constant doesn't change. So derivative of a constant is 0. Students, are you all there? Type yes in the chat box. Gayatri, Ashrita, Harika, Jyoti, Samsung.
Sir,
Yes, Gayatri.
sir, we can't send messages in chat box.
Oh. Oh, why? Okay. I'll just check with the team. It seems students are unable to send messages in the chat box. So that's okay. You unmute and speak, Gayatri. Okay? That's okay. All we need is interaction. You can unmute and speak.
Okay, sir.
Now you can send, but feel free to unmute and speak, Gayatri. All right? Okay, regular classroom laga interact చేద్దాము. Online ఉన్నా కూడా regular classroom laga interact చేద్దాము.
Okay, sir.
Okay,
Good,
sir.
Gayatri. Yeah, good. All right. Now look at this. Derivative of this is this. These derivations we'll do when required. And Samsung, I don't know what your name is. Please change your name or let me know your name. Your device name is shown here. Would you please change your name or let me know your name? Samsung, if you tell your name, we will change your name here. Your device name Samsung is shown here. What's your name? All right. You're not responding. All right. Let me not waste time. All right. Now look at this. Now there are certain rules of differentiation. One says if I've got a function f of x plus g of x, so derivative of this one dy dx is f dash x plus g dash x. That means y dash x is equal to f dash x plus g dash x. That means I can separately differentiate. Whenever I have a sum or difference of functions, I can separately differentiate term by term. Now let's say I've got a product of functions, f of x into g of x. In that case, my dy dx would be f dash x into g of x plus f of x into g dash x. So I'm differentiating one by one and taking the product. F dash g plus f g dash. Let's apply this for some cases. Now let's say I've got x sin x. I want to differentiate x sin x with respect to x. So what do I get? First function, let us say x is f of x and sin x is g of x. So what does it say? F dash g plus f g dash. So what is f dash? Derivative of x is 1 times g. Why is it 1? Derivative of x is 1. X power n is nx power n minus 1. So x power 1 would be 1 into x power 1 minus 1, which is equal to 1 into x power 0, which is 1. So that's why derivative of x is 1. All right. Plus x into derivative of sin x, which is cos x.
Cos x.
Yes, good. Interact like that. Very good, Gayatri. So it becomes x cos x plus sin x. So my y dash would be x cos x plus sin x. So we'll do 4 or 5 problems as such, or 2 or 3 problems like this, and we'll move on to the next rule. This is the product rule. All right. Now another would be, let's say x e power x or x square e power x. Y is equal to x square e power x. So let the first function would be f of x, and this function would be g of x. All right, let this be f of x, let this be g of x. So I'll have dy by dx, or dy dx more technically. First function is, what derivative of first function is 2x. Why is it 2x? Yes, good. X square would be 2 into x power 2 minus 1. So 2 into x power 1, which is nothing but 2x. So x square is 2x, derivative of x square is 2x times g of x, which is e power x, plus f of x as it is, x square times g dash x. What is g dash x?
E bar x.
E power x. Excellent. Gayatri, excellent. So I'll do this way. I'll take x e power x common. I'll get 2 plus x. So this is my dy dx. All right. I'll do one more. I want you to answer the way you have answered just now.
Okay, sir.
Can I erase it?
Yes, sir.
All right. Students, I'm here for each and every one of you. I want everyone to interact, everyone to learn from me, squeeze out the knowledge I've got. Even if it's online, let us pretend it's offline and let's interact that way. I really appreciate Gayatri for interacting that way. I suggest others also to interact that way. All right. So I've got x cube, let's say ln x. Ln x is nothing but log to the base e is ln, natural log. So I've got x cube, let x cube be f of x, let ln x be g of x. So derivative of x cube is, what is derivative of x cube? X cube would
3x.
be,
3x square.
excellent, 3x square. How do I get that? N x power n minus 1. So 3x power 3 minus 1. 3x power 2. 3x square. So 3x square ln x plus x cube. What is the derivative of log x to the base e? 1 by x. So I've got 3x square ln x plus 1x is cancelled out, x square. So I'll have x square times 3 log x plus 1. Now this is the derivative of this function. Is it clear?
Yes, sir.
All right, good. Ashrita, Harika, others, is it clear?
Yes, sir.
Okay. Harika, you were not regular, so I think you will have difficulty in understanding. All right, now let's go to the quotient rule, where I've got a function y is equal to fx by gx, g of x. So y dash, which is dy dx, would be g dash gf dash minus fg dash by g square. This is little confusing to remember, but somehow you remember. And there's no mnemonic for it. Shortcut, I don't know how do you remember, but you with practice, you can remember. Gf dash minus fg dash by g square. Now let us do sin x by cos x. So let this be fx, f of x, and let this be g of x. So cos x times derivative of sin x, which is cos x, minus fg dash sin x, derivative of cos x is minus sin x by cos square x, g square, no? Cos square x. So this minus into minus becomes plus. I'll have cos square x plus sin square x by cos square x. Which is nothing but 1 by cos square x, because cos square plus sin square is 1. 1 by cos square x, which is nothing but secant square x. And that's what we got here. All right, so derivative of tan is secant square x. How did I get this? Using quotient rule. Gf dash minus fg dash by g square. Let sin x be f of x, cos x be g of x. Cos x into derivative of sin x, which is cos x, minus sin x into derivative of cos x, which is minus sin x, by cos square, because g square, cos square x. Cos square plus sin square is 1 by cos square, which is secant square x. All right, let's do one more quotient. And we'll give you DPP, students, in which you'll have practice of all these questions. So let me move towards physics. We are still into mathematics. So that's why I'm going a little quicker, but you'll have a DPP and then you'll have a doubt session where you can clarify all your doubts from DPP. DPP is nothing but practice sheet, daily practice sheet, which has got hordes of questions this time. All right, now let us find out y is equal to e power x by 1 plus e power x. I want to find the derivative of this one. So dy dx is equal to 1 plus e power x g. This is g of x. This is f of x. And the formula is gf dash minus fg dash by g square. So dy dx is equal to 1 plus e power x g into f dash. What is f dash? What is derivative of e power x? E power x. That's a very beautiful function. This significance in physics we'll see. Derivative of e power x is itself e power x. All right. It has got a significance in physics. We'll talk about it later. But I'm just reminding you, or you can remind me later. It has got a significance in physics. It's a beautiful function. 1 plus e power x. We are just seeing the operation, how to operate on functions. The significance and meaning behind it, we'll look into it as we enter into physics. Physics to enter in we'll see the significance and beauty of these functions. But right now we are just seeing how to operate on these functions using derivatives. All right. So 1 plus e power x, derivative of e power x is e power x minus fx, derivative of 1 plus e power x. What is derivative of 1 plus e power x? Constant plus e power x. 1, derivative of 1 is 0, plus derivative of e power x is e power x by 1 plus e power x whole square. Now that would be, this is 0, e power x into e power x, e power x into e power x gets cancelled out. All right, I'll expand. So e power x plus e power 2x minus e power 2x by 1 plus e power x whole square. So this e power 2x gets cancelled out. I'll get e power x by 1 plus e power x whole square. Now this is my derivative of that function. Is this okay? All right, I hope this is okay. Is this okay, students? Is this clear? So product and quotient, both we have done.
Yes, sir.
Yes,
right.
sir. Okay.
All right, good. Now let's move on to chain rule. Chain rule is interesting and little confusing. Chain rule is also called outside inside rule, or that method is called onion peeling method. ఒక అనియన్ ఉంటుంది కదా, దాన్ని లేయర్స్ ఉంటాయి కదా, 1 by 1 లేయర్ తీస్తే లోపల ఒక లేయర్ బయటకు వస్తుంది, మళ్ళీ ఇంకొక లేయర్ తీస్తే ఇంకొక లేయర్ బయటకు వస్తుంది. సో దట్ ఇన్ దిస్ ఆల్సో విల్ బి మూవింగ్ లేయర్ బై లేయర్, function by function, outside to inside. That's why it's called outside inside function, outside inside method, or onion peeling method. All right, interesting. Look at this. It's funny and interesting. I mean, the name is funny, but the method is interesting. Now let us say I've got y is equal to sine of 2x. All right. So what I do in this case is, now there are function inside a function. I have got a f of x, g of x inside f of x. What is g of x here? 2x. What is f of x here? Sin x. So I've got a function within a function. So what I do, I go to the outermost function, differentiate it, then I go to the inner function, differentiate it. If there is further inner function, I'll differentiate it. If there is further inner function, I differentiate it. So this method is called outside inside method. I go from outside to inside. All right, let's see how. What I do, we'll do some 10 problems in this. You'll become very comfortable in this. Don't worry. I'll not go into the deeper mathematics of it. We are just doing how to operate on different on functions using derivatives. So what I do, dy dx would be, outer function is cos, derivative is cos. It is sine, derivative of that is cos. I write the whole of the remaining function as it is. I now go inside the function, which is 2x. So derivative of 2x is 2 into x power 0, which is nothing but 2. Right? Is it okay? Derivative of 2x is 2, convinced, right?
Yes, sir.
Okay. Gayatri, I really appreciate you, but others are not responding at all. Students, if you are able to follow, that's fine. If you are not able to follow, please let me know. All right, you can either type in the chat box or speak. You've got liberty to do both. Any of these, either of these. Okay, now that becomes 2 cos 2x. So dy dx is 2 cos 2x. Now let us see sine of e power x. So dy dx would be, outer function is sine, derivative of that is cos. I write everything as it is. Times, I go inside the function. What is in inner function? E power x. Derivative of e power x is e power x. So that becomes e power x cos of e power x. That's the derivative. Now let's do a little more complicated. Outside inside rule. I'm going from outside to inside. I've got sine of e power 2x. So y is equal to this. So I've got f of g of h of x. F is sine, g is e power, h is 2x. All right, we know e power x is e power x, but I don't know e power 2x. But chain rule tells me what it is. So now dy dx would be, derivative of sine is cos. I write everything as it is. Times, I go inside the function now. What is the inner function? E power 2x. What is derivative of e power 2x? E power 2x itself. E power the same function. Now I go inner function now. I go inside, further inside. What is the derivative of 2x? 2. So that becomes 2 into e power 2x cos e power 2x. Now that's my derivative. Now let's do this one. Sine of e power x square. How do we do this? So outer function is sine, derivative of that is cos. Everything is as it is. I go inside the function. What is the inner function now? E power something.
E
So
power,
derivative of e power, sorry?
E power x.
Brilliant. So that becomes e power x square because e power that function. Right? Dot. Now I go further inside. What's the inner function now? X square. Derivative of x square is 2x.
Yes, sir.
Good. So
Yes,
that becomes
sir.
2x e power x square cos of x square. So that is dy dx. All right, I'll give you one more. Y is equal to ln e power x square. So dy dx would be, what is the derivative of log, natural log? 1 by x. 1 by that function, 1 by inner function. So I write 1 by everything as it is, e power x square times, what is the inner function now?
E power x square.
Brilliant. So derivative of that would be e power something. So e power as it is, e power x square times, what is the inner function now? Further inner function?
X square.
X square. Derivative of x square is
2x.
so this e power x square is cancelled out. So I'll have 2x as derivative. All right. Now let's do one more. Sine of 1 plus e power x square. So dy dx would be outermost function is onion peeling method. I go on peeling the function. Outer function, then inner function, then inner function, then inner function, then innermost function. Till I reach the innermost function, I go on differentiating. All right. So outermost function is sine. Derivative of that is cos. Everything as it is. Times inner function is 1 plus e power x square. Derivative of that would be e power x square times 2x. That's my derivative. Right? Now let us look at one confusing one. Sine square x. Are you able to see, students? Is the marker clear? So derivative of sine square x would be, I can do this in two ways. One is sine x into sine x. Product rule. I can do it this way. So f of x and g of x, f g dash plus f dash g. I can do it that way. That is one way of doing it. But look at chain rule. What is my outermost function here?
Sin x.
It is square. X square. I mean function square. X power n. X power n is the outermost function here. Sin x is not the outermost function. All right. So this becomes 2 sin x, everything as it is, times derivative of sin x is cos x, which becomes sin 2 sin x cos x. All right. Now look at this one. Sin x square. Here my outer function is sine. Here outer function is square. Function square, x power n. Here outer function is sine. Inner function is x power n. Here outer function is x power n. Inner function is sine. All right.
Yes, sir.
Okay. So this is about chain rule. Now, no matter how many functions you have, let us say you have got hell lot of functions. Yes, I'll take 3 functions or 4 functions together. I'll write tan of, sine of, cos e power x square. I'll write this function. Let us differentiate this one. Some random function I've written. All right. I don't know whether it has got physical significance or not, but we will deal with functions which have got physical significance. Mechanical and geometrical significance are important for physics. For you to rule in physics, these two perspectives are important. Mechanical and geometrical. But in this case today, till now we have been doing just the operation, how to operate on functions and find derivatives using rules, product rule, quotient rule, and chain rule. All right. Derivative of sine or tan.
Secant square x.
Excellent. So I'll write secant square, everything as it is. Sine, cos, e power x square. Next, I go to the inner function. What is my inner function? This is my inner function. What is the derivative of that?
Cos.
Excellent. Cos, everything as it is. I go further inside. I'll erase this. This is done. I go further inside. What is the inner function now? Cos e power x square. So that becomes minus sine e power x square. I go further inside. What's my inner function now?
E power x square.
Excellent. Derivative of that would be
E power x square.
times, I go to the inner function now, innermost function.
X square.
X square. Derivative of that is
2x.
Now that is my derivative using chain rule. All right. It is some crazy function. I don't know whether it has got some physical significance or not. It's some crazy function. We know how to do the chain rule now. Are you all now comfortable with chain rule?
Yes, sir.
All right. Now let us move on to integration. Students, I've got derivative of sine x was cos x. So if I write d by dx of sine x, I'm getting cos x. All right. I'm again telling you, I'm just telling you how to operate on functions. Its mechanical and geometrical significance will enter into it. We say integral of cos x with respect to x is sine x. All right. Derivative of sine is cos. Integral of cos is sine. All right. But now look at this. If I've got integral of cos as sine, now let us say I've got sin x plus some constant c. So what is the derivative of this function? D dx of this function?
Integral of cos x plus 0.
No. Only derivative of this function. Just the derivative of this function. What is the derivative of this function?
Cos x.
Cos
Excellent. Why is it cos x? What happens to constant?
0.
Then becomes 0, sir.
0. So that is cos x. That means integral of cos x can be sin x plus c also.
Yes, sir.
If I say it is 2, it can be sin x plus 2 also. It can be sin x plus 3 also. It can be sin x plus 4 or any number, any real number here. I can represent it by c. So integral of cos x dx is equal to sin x plus c. All right. Anyways, derivation of this integral is not important now. Now you'll do it in math, even if you don't do it over there. We'll again do it when required. Right now, we are just trying to operate on functions. So integral of cos x is sin x plus c. Integral of, I know the derivative of cos is minus sine. Right? And derivative of tan is secant square. Derivative of this is that. So integral of this would be cos x plus c. Minus comes over here. So minus cos x plus c. Integral of secant square dx would be tan x plus c. Is it clear, students? If I know derivative of this one, the inverse operation, reverse operation of that would be integral of cos x is sin x plus c. All right. Is it okay? Just okay?
Yes, sir.
Okay. Ashrita, is it okay? And
Yes,
Jyoti?
sir.
Yeah. And who else is there? Omkar is here. And is Rakshit here? No. Okay. Gayatri, Ashrita, and Samsung, you haven't told me your name. Samsung, third student over here, hasn't told me your name. All right. So I don't know how to address you. Now look at this, students. This is called indefinite integral. Indefinite integral means I don't have any limits between which I'm integrating. I've got a function, I integrate that with respect to dx, x, which is cos x dx, that will result in sin x plus c. All right. there is something called definite integration, which is very useful in physics. In physics, we'll have only definite integrals. Indefinite integration, we can get this constant. This constant is some constant, right? I can get this constant from the conditions of the problem. All right, some physics of the problem, some condition of the problem given in the kinematics or some mechanics of the problem. I can get this constant from the problem. There is another kind of integral which says definite integral. Which says integral x1 to x2 f of x dx. Now let us say f of x is sin x or cos x. Integral x1 to x2 cos x dx is equal to sin x under the limits x1 to x2. Look at the notation, students. I don't have plus c here now. That constant is hidden in limits. That constant is being acquired from limits. How you will understand later. But right now, you just understand the notation. Integral x1 to x2 cos x dx is sin x under the limits x1 to x2. Now, how do I evaluate these limits is, evaluate the sin x right hand side is this way. Sin of x2, I substitute the upper limit minus sin of x1, I substitute the lower limit. Now, this gives me the number, which is this integral. So, definite integral gives you a number. All right. Now, yesterday we have seen this graph half gt square. Sorry, I need ink over here. And velocity v is equal to gt. I got this information v from this graph by differentiating. Right? I got this information from this one by differentiating. That's what we have seen yesterday at the end of the session. But I also told you I can get this information from here by calculating the area under the graph. Let's say I've got t. So this interval is t and this is gt. So area would be half gt height into base into t, which is nothing but half gt square. So I got this information from this graph. So any graph will give you whole of the information of the motion or phenomena. All I have to do is extract the information. So if I want to extract this information from VT graph, information about displacement from VT graph, I find out the area. All right. Yesterday I told you that area is giving me information about this one, but slope of this one is giving me information about this one. All right. Now, let us do one thing. And what was done in math yesterday? Integration, right?
No, sir, differentiation.
Differentiation only. All right. All right.
Sir.
So are you able to understand what I'm speaking?
Yes, sir.
Yes, sir.
Others, are you able to understand what I'm speaking? Ashrita?
Yes, sir.
All right. All right. Now look at this. Integral derivative of x power n is nx power n minus 1. But whereas integral of x power n dx is equal to x power n plus 1 by n plus 1 plus c. If I want to get rid of this constant, I'll apply some limits x1 to x2 under the limits x1 to x2. Is this clear, students? This is a formula. For x power n, I've got x power n plus 1. N plus 1 by n plus 1. As you had a formula n x power n to nx power n minus 1, for differentiation. For integration, it's a x power n, you have got x power n plus 1 by n plus 1. All right. Is this okay, students? Is this equation okay?
Yes, sir.
Good. All right. Now let us find out integral x dx between limits 1 to 2. What do I get? Integral x is what? X power 1. X power 1 plus 1 by 1 plus 1. So x power 2 by 2.
Yes.
Under the limits 1 to 2. So I substitute the upper limit first. 2 square by 2 minus, I substitute the lower limit then, 1 square by 2, which gives me 1, 2 gets cancelled out, 2 minus 1 by 2, which is 3 by 2. All right. Now let us look at one thing. I'll plot y is equal to x graph. When I plot y is equal to x graph, I'm integrating it from 1 to 2. So 1 to 2. 1 to 2. Let me find out this area. And let's see what we are getting. If this is 1, this is 1. If this is 2, this is 2. So the area of this would be, this is 1, this is 1, this is 1, this is 1, this is. So area of this will be area of triangle plus area of a square. What is the area of the triangle here? Half into base into height. Base is 1, height is 1, plus area of the square here, 1 into 1, which is 3 by 2. See, area under the graph, I got it as definite integral of this graph. All right, I am not proving it. I am just giving you an example. Proof, we'll look into it later. But example says that area of this function, f of x, under the limits 1 to 2, that means from 1 to 2, is area under this graph. Or definite integral gives me area under the graph. I just found out the definite integral using the formula, I got 3 by 2. I found out the area under the graph, I got 3 by 2. All right, so I'm giving an example which says integral f of x dx, x1 to x2 is nothing but area under f of x from x1 to x2. Is this clear, students? I'm not proving it. I'm just stating it. Here I have verified it, and I'm just stating this general result. Is this clear, students? When I integrate f of x dx, we have got formulas for integration. As we had formulas for differentiation, I can integrate this. That will give me nothing but the area under the fx curve between x1 and x2. Is this clear, students?
Yes, sir.
Yes, sir.
Sure, Gayatri, are you sure you are clear?
Yes, sir.
All right, Ashrita.
Yes, sir. Clear.
All right, Manoj says okay. All right. I'll just take a minute. I'll just take a minute and tell you something interesting. Proof of it, I'm telling you, we'll look into it again. Don't worry about the proof right now. All right, we need proofs as well, but right now not. You don't need any proof right now. I'm just telling you a statement which says integral f of x dx from x1 to x2 is equal to area under the fx curve between x1 to x2. All right, now let us do some areas. I want integral -1 to 1 x dx is what? Area under y is equal to x graph. Same function I'll draw. F of x, I'm drawing the same function f of x. So x, I'm drawing x, y is equal to x. From -1 to +1. I can do it this with formula. What's the formula? Formula says x square by 2 under the limits -1 to +1, which is nothing but I'll substitute +1 first. 1 square by 2 minus, I'll substitute the lower limit, -1 whole square by 2, which is nothing but 0. I got it as 0. Now look at this. Lower area is considered as negative, upper area is considered as positive. It has got physical significance, but right now just consider lower area as negative, upper area is positive. So this area is equal to this area. These two get cancelled out and I get 0. Is it clear? I'll just take another minute. I'm really sorry. Now let us do sin x. Now with this logic, you tell me integral sin x dx from minus pi by 4 to pi by 4 is equal to, or minus pi by 2, let's say, minus pi by 2 to pi by 2. With this logic, this area is equal to this area minus pi by 2, pi by 2. Now my area should be 0. Now let us do it with formula. What is integral sin x minus cos x? Right? Minus cos x under the limits pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Now what I do, I substitute the limits. Upper limit first, then lower limit. Minus of cos of pi by 2 minus cos of minus pi by 2. What is cos pi by 2? 0 minus 0 minus of that, which is 0. I'm again getting 0. What I got from graphically, I got 0. And numerically also, using the formula, I got 0. The point is, whenever you have a definite integral, we quickly plot the graph and find out the area. All right. Finding out the area sometimes through this is very easy than this. This had a couple of steps, but this I could quickly answer that it is 0. All right. There are cases in physics where you will have to quickly answer. You can quickly answer using graph. All right. Now, for example, all right, I think I should stop here because sir would be waiting. All right, students, was it clear till now?
Yes, sir.
Was everything clear? Ashrita, Manoj?
Yes, sir.
All right. No, please be frank. All right. It is all for your good. If you're not frank, I will not know whether to go ahead or not. All right. I would like to stop here and hand over the session to Gurvinder sir.
Hello. Good evening. Am I
Good evening, sir.
audible?
Yes, sir, you're audible.
Okay, great. So hi, good evening everyone. Gayatri, homework किया था तुमने? I saw that. How about others? Seems like we have some new faces today. Yeah, Ashrita is there. Manoj, hi. Okay. Yeah, so I'll start today's session. Okay. I hope you must have received yesterday's notes, right? Did you receive yesterday's notes? कल
Yes,
के
sir.
notes मिले थे? Okay. So did you refer to it?
Yes, sir.
Okay, great. Good to hear that. I will be discussing the problems today because I saw your homework. The first question was solved correctly. There were some issues in other problems. So after I end this session, I'll be discussing about that chain rule thing again. Okay. Okay. So yeah, we'll be starting today's session. So today we'll be discussing about what the derivative at any point of a function tells us. Okay. So like, for example, you have a function y is equal to f of x. Okay. You find its derivative at, Okay. So basically, like we have this curve, you plot its tangent at any point, and then you check the slope of the tangent, like the angle from the x-axis. So if at any point the slope of tangent turns out to be positive, can you infer something from that? Can you infer something? Positive means the curve is going something like this. Like the angle it is making with the positive x-axis lies between the minimum angle that this tangent is making with the positive x-axis lies somewhere between 0 and pi by 2. So if at any point the slope of the tangent is positive, it means at that point the function is increasing. Okay. At that point the function is increasing. Okay. So similarly, if at any point the slope of tangent is negative, it means the function is decreasing at that point. Okay, so what do we mean by the word decreasing and increasing? Like in decreasing sense, it would be something like this. So compared to x-axis, it will be going downwards, right? At any point you find the slope. Okay, so tell me any function. Ashrita, tell me any function, polynomial function. Ashrita?
Sir,
Yes, yes. Tell me any function, polynomial function.
2x
Sorry?
square
Okay.
plus 8x plus 6, sir.
Okay. So Manoj, find its derivative. What will be its derivative? Tell me. Okay. So you want this one. Okay, we will do in both. So tell me its derivative. What will be its derivative? What will be its derivative? Tell me. Tell me. What will be its derivative? It's 10x plus 9. And इसका क्या होगा?
2x square plus 6. 2x plus 6. 8.
Will it be 2x? It's already 2x square
Yes, sir. 4x.
plus 8, right?
Yes, sir.
Because, okay, 4x plus 8, right? It will be 4x plus 8, right? Okay. So now I am telling you that find the slope of this curve at x is equal to 1. So what will be its slope? Tell me. At x is equal to 1, what will be its slope? And
0.
its slope will be 0?
Yes, sir.
No. How do we find the slope? Tell me, how do we find the slope? The slope is basically, you got this derivative, right? This derivative means the slope of this function at any point. So you have x is equal to 1, you just input x is equal to 1 over here. So it is slope is 12, right? Similarly here, I am asking you find the slope at x is equal to 0. So what will be the slope at x is equal to 0?
9.
Yes, exactly. Ashrita, you know this, right? How do we find the slope?
Yes, sir.
How do we do it? Tell me. Is there something confusing here? Something you are not getting? Right? See, the derivative of any function is basically what? It is the slope of the curve at any given value of x. So basically, if I have any curve y is equal to f of x, I differentiate it. Okay. I differentiate it, I get some function. Now, if I am asking you to find the slope of f of x at any given value of x, so how will you do it? You will just input this value over x over here, and whatever the result comes out to be, that will be your slope of f of x, right? This is the basic.
Yes.
This is the basic we had learned. Okay, so y is equal to 2x square plus how much was it? 8x plus 6. So okay, so it's dy by dx is 4x plus 8. Okay, so what will be its slope at x is equal to minus 1? What will be its slope? Tell me, what will be its slope? The slope of
4.
y, yes, it will be 4. Okay, so can I say that at x is equal to minus 1, y is increasing? Can I say that? Yes, because its slope is positive.
Yes, sir.
Okay, slope is positive. Similarly, if I ask you to find the slope at x is equal to minus 3, so what will be its slope at x is equal to minus 3? Tell me, what is the slope of at y is equal to minus 3?
-4.
-4.
Yes, minus 4. It is minus 4. Sorry. Yeah, it is minus 4, right? 4 into minus 3 plus 8. So it is minus 4,
Yes, sir.
right?
Y is
So that
decreasing.
means y is decreasing at that point. Why? Because slope is negative,
Yes, sir.
right? So
Yes,
now,
sir.
if I give you any function, so we will do that other problem also. We'll do that other problem also. So y is equal to 5x square plus 9x plus 4. Okay. So what is its dy by dx? dy
10x
by
plus
dx. Okay.
10x.
10x plus.
9.
Okay, great. Great. Good to hear that. Manoj, is that you?
Yes, sir.
Okay, great. Were you present in yesterday's class?
No, sir.
Okay. Okay, no issues. Okay, great. So its slope at x is equal to 1. What is its slope at x is equal to 1?
19.
19, exactly. Exactly, 19. Okay. Its slope at x is equal to minus 1. What is its slope at x is equal to minus 1?
-1.
Yes,
Minus
exactly. Minus 1. So that means
Y is
at x is
decreasing.
at x is equal to 1, it is increasing.
Sir.
And at x is equal to minus 1, it is
Decreasing.
decreasing. Right? I can say this. समझ आ रहा है ना?
Yes, sir.
Easy. This is easy, right?
Yes, sir.
Okay, great. So now basically what happens is when we take the differentiation of any function, okay, I have a function y, some any random function f of x, okay. I take its differentiation. Okay, so it is often represented like this with a 1 dash. Okay, so basically I get the points where the function may be increasing. I also get the points where the function is decreasing. So there are a few points where slope of function is 0. Okay. So if slope of the function is 0 at any point, it means basically something like this. Okay. What does it mean? It basically means that at that point, with the x-axis, the curve, the tangent is parallel to the x-axis. That is what it means if the slope is 0. And such points where okay, let us not call it derivative now, where dy by dx turns out to be 0, such points are called critical points. Okay. Okay. Do you get that? Because these points will tell us something about the function later on, which will be very critical for us to know about the function, which will be very important for us to know about the function. Okay. So such points where dy by dx turns out to be 0, such points are called critical points. Okay. So first of all, we will do this basic problem only. 2x square plus 4x plus 3. Find its critical points. Okay. How will you do that? How will you do that? Manoj, tell me.
Sir.
Yes.
Uh,
Don't hesitate.
sir.
Tell. See, what is the definition of critical point? No, that is not correct. Okay, no, not an issue. See, what is the meaning of critical point? I have told you earlier also. Critical point means where the slope of that function is turning out to be 0. Yes, exactly. Great. You are doing awesome. So Manoj, see, what will be its slope? What will be its derivative? Manoj, tell me its derivative.
4
Hmm.
plus
Okay. Sorry, I couldn't hear you. Gayatri, can you tell me?
Yes,
We
sir.
did this earlier also. Okay, tell me, what will be its derivative?
4x plus 4.
Okay, great. 4x plus 4. And now I am telling you to equate this thing to 0, right? So x is equal to,
Minus 4, minus 1.
exactly. So x is equal to -1 is the critical point. There is only one critical point. Okay. There is only one critical point to this function. Okay.
Okay.
Okay. So, okay, I'll give you one more problem. Okay. Tell me its critical points of this function. Okay. See, I know you guys are getting bit confused because sometimes I write y, sometimes I write f of x. So just treat it to be something like this. Both are equal only. Okay. So what is dy by dx? Okay, so okay. Manoj, बताओ.
1 by 27x.
1 by 27x. No. No. Do you know how to find the derivative of a function? What is the formula for derivative of x raised to n? Tell me. What is formula for derivative of x raised to n? Tell, do you know it? Gayatri, do you know the answer to this?
Sir, is it 3x by 3 whole square?
So what is 3x divided by 3?
3 will get cancelled, x square.
Yes. Okay. Okay, so Manoj, I guess you should look at my previous lecture. Okay, because there I had taught you. See, the derivative of x raised to n is n x to the power n raised to minus 1. Okay, so what will be the derivative of 1 by 3 x raised to the power 3? See, 1 by 3 is a constant, it will come outside. Okay, so we have x cube left. What is the derivative of x cube? Okay, yes, great. Okay, it's something like this plus 4x plus 3. So it is x square plus 4x plus 3. And I'm asking you to do it to 0. So x is equal to minus 1 and minus 3. Yes, it's correct. Good to hear that. Manoj,
Yes,
did
sir.
you get it?
Yes, sir.
See, x raised to n's derivative is n multiplied by x raised to n minus 1. So here we had 1 by 3 multiplied by 3x square plus then 4x plus 3. Gayatri, did you know this thing? 1 by 3, how to do that 1 by 3 thing?
Yes, sir.
Okay, great. Because you got the correct answer, so I am assuming that you must have done it through the correct method, right? Okay, great. So you guys have found out, like now we have found out what critical points are. Okay. So basically there are 4 types of critical points. Four types of critical points. Basically means there are 4 types possible where at any point the derivative is 0. Okay. मतलब अगर एक पॉइंट पे डेरिवेटिव 0 हो रहा है, so there are only 4 possibilities. See, what are the 4 possibilities? कि उससे पहले उससे लेफ्ट साइड पे डेरिवेटिव पॉजिटिव रहा हो, उसके राइट साइड पे भी पॉजिटिव रहा हो, उसके राइट साइड पे भी पॉजिटिव हो, देन प्लस ऑन द लेफ्ट, राइट ऑन माइनस ऑन द राइट, देन माइनस ऑन द लेफ्ट, प्लस ऑन द राइट, minus on the right, minus on the left. Is there any other possibility left? No, right? If differentiation of a derivative of a point is 0, if derivative of a point is 0 at any point, then only these 4 possibilities are left. That either to its left and right, either it could be plus plus, or it could be plus minus, or it could be minus plus, or it could be minus minus. Right? You get that, right?
Yes, sir.
Okay. Okay, great. Okay, good. Okay. ठीक है, तो अब यही 4 पॉसिबिलिटी है. अब इन चारों पॉसिबिलिटीज को वी विल बी विजुअलाइजिंग इट थ्रू अ बिट, like we will be visualizing it through drawing it. Okay, so first we will try out this. First I'll do it below. Okay, so first we will be doing that minus plus case. Okay, what is meant by minus plus? We have this point. At this point the differentiation is 0. Before this point it was minus, and after this point it is plus. Okay, so that means before this point had come into picture, this function was decreasing, it was having negative slope. When this function came, the slope came parallel to x-axis, and after this point it began to increase. So the function went something like this. Okay, this is just a representative picture, doesn't mean the function has to be like this. Yes, but one thing I can guarantee is function की property ऐसी ही होगी. अगर इस पॉइंट से पहले स्लोप नेगेटिव है और इसके बाद इंक्रीजिंग है, इट मींस बिफोर दिस द फंक्शन वाज कमिंग डाउन, it came at this point where it turned out to be parallel to x-axis, and after this point it is increasing, it is going up. So we call such a point minima. You can see this point will act as a minimum for this function. The value of f of x will be minimum at this point, right? It will be minimum at this point. Why? क्योंकि उससे पहले कम हुआ और उसके बाद ऊपर चला गया. First it came down and then it increased, so there was no other chance. Okay. Similarly, now I'll be discussing the second point. Second is what? Plus minus. What does plus minus mean? Plus minus means before this point came into the picture, the function was increasing, it was going up. After this point, it was coming down. Okay. And at this point, it is turning out to be 0. So if it is turning out to be 0, it means it is a, what we can call it? It is a maxima. It is a maxima. Why? Because this point is giving the maximum value. So the function will have maximum value at this critical point. Okay. Are these two clear? Manoj?
Yes,
Manoj,
sir. Yes, sir.
समझ आ रहा है? हिंदी आती है?
आता है.
Okay, okay, great. Gayatri, what about you?
Yes, sir.
समझ आ रहा है?
Yes, sir.
Ashrita? Okay, great, great. Good, great.
Yes, sir.
Okay. So the remaining two, okay, the remaining two, that means minus minus and plus plus. If I try to evaluate it, what is happening is, see, first also this function was decreasing. After this also the function is decreasing. Only there is one point coming where its slope is parallel. मतलब पहले भी function नीचे ही जा रहा था, बाद में भी नीचे ही जा रहा है. कोई फर्क नहीं पड़ा. Similarly, we have something like this. So first also it was increasing only. It was increasing. After that also it is increasing. So these 2 points are faltu. Faltu means useless. These 2 points are neither maxima nor minima. Right? You can see that clearly. Because first also it was going down. After that also it is going down. No use. Neither minima nor maxima. Such a point is called point of inflection. Point of inflection. Okay? Fine. Okay, so we will do a problem on it. Okay. So, okay, so Manoj, tell me any quadratic equation.
6x square plus 4x minus 3.
चलो तो सबसे पहले तो इसका क्रिटिकल पॉइंट, इसके क्रिटिकल पॉइंट बता दो. हाउ मेनी आर देयर एंड व्हाट आर इट्स वैल्यूज? टेल मी इट्स क्रिटिकल पॉइंट्स. But for that you should know differentiation, which I guess you were not. अच्छा, आश्रिता बताएगी. आश्रिता ने कल से भी कोई आंसर नहीं दिया बहुत टाइम से. आश्रिता, टेल मी.
36x plus 4.
How much?
36x plus 4, sir.
36x? No, it is 6x square, not 6x to the power 6.
Sir, is it 12x plus 4?
Yes, exactly. Ashrita, x raised to n का क्या होता है डेरिवेटिव? Tell me. What is the derivative of x raised to n? Ashrita?
nx nx n minus 1 sir.
Yes. So x is x square, right? X square का क्या होगा? It will be 2x, right?
Yes sir.
So multiply, it is getting multiplied by 6.
Yes sir. Yes sir.
So it is 12x. Okay.
Okay sir.
You have you revised yesterday's? You should revise, okay? Otherwise, we will be stuck at this backlog things. Okay. Okay. So tell me, what is the value of its critical point? Manoj will tell me. Manoj,
Sir,
critical point बताओ.
point
Critical point कैसे निकालते थे? अभी तो बताया था यार.
0 होना sir.
Sorry. Yes, Gayatri. Correct. Manoj, tell me how critical point, how it is evaluated. How is a critical point evaluated?
The answer should be 0 sir.
Answer means like, what are you trying to say? I'm not able to understand. Like you are trying to say x is equal to 0 is a critical point.
No sir.
Okay, so like what are you trying to say? Tell me.
X should be like that the answer should be came 0.
Okay, so you mean dy by dx should be 0. So I'm asking, what is the value of x? What is the critical point? If dy by dx is turning out to be 0, what is the value of x? Ashrita, tell. It is minus 1 by 3, right? 12x plus 4 is 0.
Yes.
So 12x is minus 4. So x is minus 1 by 3. Okay.
Okay sir.
Okay.
Okay sir.
Okay. So we have this point minus 1 by 3. Okay. So if I put a value minus greater than minus 1 by 3 in its slope, can I say that the slope will be positive and below this it will be negative? Can I say that? You can try and see also. You can try and see this. If you put if x is greater than minus 1 by 3, slope will be positive, and if x is less than minus 1 by 3, slope will be negative. You can try this also. In you have the slope now 12x plus 4x. You can substitute any value greater than minus 1 by 3. You can substitute any value lesser than minus 1 by 3. It will turn out to be negative. This will be positive. So what can I infer about this point? That first it was decreasing, then it is increasing. So what can we say about this point? What can we say about it? We can say that this is a minima. Can we say that?
Yes sir.
Right? Okay. So, okay, one more problem. Okay, इसका critical point बताओ. Tell me its critical point.
Minus 8 by 12.
Okay, so just a second. Minus 8 by 12. Okay, so it's minus 12x plus 8. Actually, no. It can't be, it shouldn't be minus according to me. It should be a positive value. Ashrita, आया?
Sir.
हाँ, tell. हाँ, tell. Manoj, were you speaking? Tell me the answer.
So it shouldn't be minus sir.
Okay, correct. So what is the answer? Tell me the value of x.
minus 8 by 12.
So earlier you told me that it shouldn't be minus, and now you're again telling minus 8 by 12.
Then how to do?
See, what is its derivative? First, tell me its derivative. What is its derivative?
Minus 12x plus 8.
Yes, correct. Right? And I have to make it to 0. I have to equate it to 0, na?
Yes, sir.
So 12x is equal to 8. So x is 8 by 12, right? 2 by 3. How it is turning out to be minus? Why were you saying minus?
8. Yes, sir.
Okay, okay. No problem. ठीक है, समझ आया?
Yes, sir.
Okay. So again, you keep this thing. You have 2 by 3. You have 2 by 3. Okay. So if you keep any value greater than 2 by 3, it will be negative over here. Any value lesser than 2 by 3 you keep, the slope will turn out to be positive. Okay. These plus and minus are the signs of slope I am talking about. Signs of slope that I am talking about over here. Okay. So how will this point behave? X is equal to 2 by 3 is a, what is it? What is it? First it is plus, that means पहले ऊपर जाएगा फिर नीचे आएगा.
Maximum.
Okay. Yes, exactly. This point is a maximum. Correct?
Yes, sir.
Yes.
Okay. Great. Good to hear that. Okay. Okay. इसका बताओ क्रिटिकल पॉइंट. ये तो बहुत इजी है यार, ये तो अभी हो जाना चाहिए 10 से. Okay, first tell me dy by dx.
3x square.
Okay, we have to equate it to 0, right? So what is value of x?
0.
Okay, great. 0. So I have this point 0 over here. So either you keep anything to the right on this number line or anything to the left, it is x square over here. It is x square, so it will be positive only. Okay, either you keep a negative value or you keep positive value, it will be negative, it will be positive only, because anything squared will always remain positive. Either you have put a negative number or you have put a positive number. कुछ गलत बोल रहा हूँ क्या? Am I speaking something wrong? Tell me. It is correct, na?
Yes, sir.
So, right. So how will this point behave? How will this point behave? First also it was increasing. After
Maximum.
that also it is increasing. No, no, it is not a maximum.
Flexion, sir.
Yes, sir.
Yes, correct. It is inflection. It is inflection, correct. Okay. So this is called the first derivative test. The first derivative test for maxima or minima. It is called the first derivative test. Okay. Now, many a times what happens is, for example, I have a function. Okay. I have a function. I'll treat it as a problem. I will treat it as a problem only. Okay. So you clearly understood what the first derivative test means, right? That you will first find out its derivative. Okay. तो वो उसका differentiation करोगे. Then you will check for critical points and how the values of derivative is behaving around that points. You will check it out. Okay. So the problem with this is, for example, you have a function whose derivative turns out to be something like this. Okay. Okay, I'm sorry. I shouldn't have put this thing here. It is a cubic. What I meant to say is it is a cubic function. Gayatri, वे कहाँ चली गई? ठीक है. Okay, it's something like this.
Yes, sir.
Okay. Yeah. So what I'm saying is, first of all, it will be very difficult to find its critical points. Okay.
Okay.
Okay. Right. It is very difficult to solve such a complex problem. Okay.
Yes, sir.
And even more difficult will be to like check if it is positive, negative, how it is behaving around those critical points. It is difficult. Okay.
Yes, sir.
It is really difficult to check it. So uh, instead of doing this thing, if the function get very complex, we have another method which we call the second derivative test. Okay. So what is the second derivative test? Second derivative test मुझे बोलता है, for example, I have a function f of x. Okay. I have a function f of x. Now this second derivative is telling me that what you do is you find out the critical points. Okay, you find the critical points. And once you take the derivative of this function, you take the derivative of this function again. You differentiate it again, second time. So it is represented as this. Okay. Second differentiation is represented like this. We can write it like this. Okay. Okay. So you will have some function over here, something. So what it is telling me that at a critical point, if f double dash x is positive, then it is a minima. And if f double dash x is negative, it is a maxima. और अगर f double dash x भी 0 हो गया, फिर तो फालतू फंक्शन. That means inflection. Inflection. Got it?
Yes, sir.
समझ आ रहा है? Okay, I will do a problem on it. I know it is, मतलब सुनने में थोड़ा सा कॉम्प्लेक्स लग रहा है अभी. ओके, सुनने में थोड़ा सा कॉम्प्लेक्स लगेगा अभी, लेकिन है नहीं. बिलीव मी, इट इज नॉट. इट इज much easier. It is much easier compared to this thing. Okay, so what it is telling me that first you find the critical points. Okay, I told very good, निकाल लिए सारे critical point. अब मैंने जिस फंक्शन को एक बार डिफरेंशिएट किया था उसको एक और बार डिफरेंशिएट कर दिया. I differentiated it once more, and then at any critical point I wanted to know the information. So for example, I have any critical point. Let us say x is equal to x naught. So at this x naught, I want to check if it is increasing, decreasing, or equal inflection. So what will I do? I have found out this second derivative. I will put this value x is equal to x naught inside the second derivative. If it turns out to be positive, it is minima. If it is negative, it is maxima. If it is 0, it is bekar, inflection. Fine. So we will check it with a few problems. Or we should do it through earlier problems only, right? I should do it through earlier problems only. Okay, so I will do it through this problem. So tell me, what is its dy by dx? Manoj will tell me. Manoj, tell me. dy by dx बता दो यार इसका जल्दी से.
minus 12x
अभी तो किया था. हाँ.
plus
Plus
8.
ओके, चलो अब लगे हाथ इसका सेकंड डेरिवेटिव भी बता दो. What will be its second derivative? Second derivative means you are differentiating this. Like you are differentiating the derivative. Okay. Tell me, what will be it? I couldn't hear you. Hello?
Hello, sir.
हाँ, बोलो बोलो. What will it be?
How to do it, sir?
Okay, so what is the derivative of x raised to n? Ashrita, do you know the answer?
Sir, don't know, sir.
Okay, what is the derivative of x raised to n?
Nx n power minus 1.
So what is x? It is x raised to the power 1, right? So x raised to 1 का derivative क्या होगा? x raised to 1 का derivative क्या होगा?
1x power
Hmm.
0.
So what is x power 0? Can I call it 1 only? Because x power 0 is 1, right?
Yes, sir.
Right?
Yes, sir.
So it is getting multiplied by minus 12. So 1 multiplied by minus 12. So it is minus 12 plus
Well,
then derivative of 8, that is 0. So it is minus 12 only. Okay. Gayatri, are you there? Okay.
Yes, sir.
So tell me, you got it? कैसे किया हमने? Second derivative कैसे लेते हैं?
No,
And
sir.
what was its critical point? It was 2 by 3, right?
Yes, sir.
It was 2 by 3, right? So what I am asking, you have this thing 2 by 3. Try to put this value of 2 by 3 into this function. But this function is already a constant, that is minus 12. Okay, so you don't need to put this value. Okay, so what I am saying is, when x is equal to 2 by 3, this second derivative, it is minus 12, that is negative. So that means it is a maxima. It is a maxima. Okay. Okay, so I'll just give you solve one more problem. Okay. So first find its critical points. इसके critical point बता दो. ऊपर ही कर रखा है अभी, ऊपर ही किया हुआ है. We have just done it now only. 5 minutes, 10 minutes back. Manoj, you will tell the answer, okay? This time.
3x square plus 4x plus 3.
3x square plus
Plus
4x plus 3.
4x plus 3.
Are you sure this will be 3x square? Check it once again. See, there is a 3 in the denominator also.
1 by 3 into 3x
No,
square.
no. See, what is the derivative of x raised to 3? First tell me this. x raised to 3 का derivative क्या होता है?
3x square.
This is getting multiplied by 1 by 3. So this will also get multiplied by 1 by 3. So it will be x square,
Yes.
right?
Yes,
Right?
sir.
So it is x square plus 4x plus 3. So tell me its critical points. इसके critical point बताओ. That much you can do, right? Yes, Gayatri, it is correct. Tell me, Manoj, you know how to find critical point, na? और कौन है? Ashrita, are you there?
sir.
Tell me how will you find its critical point? How will you find its critical point? Tell me. Critical point means dy by dx is equal to 0. So that
Yes,
means
sir.
x square plus 4x plus 3 is 0. Okay. So this can be written as x plus 1 multiplied by x plus 3. So x is equal to minus 1 comma minus 3. Okay. So you got that these are the two critical points. Okay, I got that. Now I will differentiate it again. for the second derivative test. अब बताओ इसका second derivative. Tell me its second derivative. See, the first derivative is this thing, x square plus 4x plus 3. What will be its second derivative? Tell me, what will be its second derivative? Second derivative means you are differentiating this thing. At least you can do of this ना. Manoj, tell me. इसका तो कर सकते हो ना differentiation. Second derivative means differentiating dy by dx. Okay, इसको हम बोलते हैं सेकेंड डेरिवेटिव. दैट पहले y से हम dy by dx पे आ गए, अब dy by dx को एक और बार डिफरेंशिएट करके d2y by dx स्क्वायर पे आ गए. इट इज रिप्रेजेंटेड लाइक दिस. दिस इज सेकेंड डेरिवेटिव. ओके, इट इज नथिंग स्पेशल.
Yes, sir.
ओके, आश्रिता टेल मी इसका सेकेंड डेरिवेटिव क्या होगा?
Sir, is it
I am
one?
not able to hear you. Tell me.
Sir, is it one?
No. See, you have to differentiate dy by dx. What is dy by dx? What is dy by dx? dy by dx is x square plus 4x plus 3. Okay. What will be its derivative? Iska. You need to differentiate this thing. Gayatri.
2x plus 4.
Yes, exactly. Ashrita, do you know how to do differentiation? Like, did you attend previous classes? Were you there yesterday?
No, sir,
Okay,
I am
okay.
not there yesterday.
Okay, no problem. So see, you have two values of critical points. The first is -1, the second is -3. So what it is telling me, in order to find if -1 and -3 are maxima, minima, or inflection, what you do is you take this function and you put this value inside over here. So what will happen if you put -1 over here? What will the value turn out to be? You put -1 over here. What will be the value? Tell me. -1 यहाँ पुट किया, क्या वैल्यू आएगी?
2i.
यस. सिमिलरली यहाँ पे पुट किया, क्या आएगी?
-2.
-3. Okay, great. So this is a positive value, right? And this is a negative value. So can I say x is equal to -1 is a, tell me, what is it? Is it a maxima or is it a minima?
Max.
See, now only I have taught you, na? If f double dash x is positive, it is minima. If f double dash x is negative, it is maxima. So what is it?
Maximum.
Oh, okay, sorry. It is a minima, right? And this is a maxima. You get that, right? समझ आया ना सबको?
Yes, sir.
आ गया ना? How we did it?
Yes, sir.
Okay, great. Okay, just a second. I am thinking of the problem. Actually, I need to calculate it in my mind first. So I need to approach it in the opposite direction first before giving it to you. Okay, fine. We will go about only this much. This is my function. Okay. सो पहले इसके क्रिटिकल पॉइंट निकालो, and then check the properties of critical point. Okay, yeah, and one thing also I had to tell you here also. See, it is -1 and it is minus, okay, sorry, it is -1 and -3, okay. So it's -3 here, something like this, it is -1. So this function -3 is behaving as a maxima, okay. -3 is behaving as a maxima and -1 is behaving as a minima. So this is what something I can refer. This is something I can refer about this function. This function, its graph will be something like this. You can plot it. There is a website by the name of desmos.com. You can check it. It is a graphing calculator. Okay. We often use it to study some like properties of some basic graphs. Okay. So you can see it. The curve to this function, the curve to this function will be something like this. It has to be like this, right? Because -3 is a maxima, -1 is a minima. So it has to be something like this. Okay. So yeah, moving ahead to this question. Critical point बता दो यार इसके जल्दी से. पहले तो डेरिवेटिव ही बता दो तुम. डेरिवेटिव
3
बता दो यार.
square minus 6x.
ग्रेट ग्रेट. अच्छा लगा सुन के. So you have to equate it to 0. ठीक है. तो x की क्या वैल्यू आएगी? x की क्या वैल्यू आएगी? Tell me.
2.
Okay. 0 and 2. One value will be 0 also ना.
Yes, sir.
0 भी तो आएगी. x की जगह 0 रखोगे तो 0 आएगा ना. Right? Okay.
Yes, sir.
Find its second derivative.
6x minus 6.
6x minus 6. Correct. So you have x is equal to 0. You have x is equal to 2. Tell me, what is its value when I put x is equal to 0 inside over here?
Minus 6.
Yeah. And what if I put 2? What if I put 2?
6.
Correct.
Minus
So x is equal to 0 turns out to be it is y double dash 0 is coming negative. So what does it mean if it turns out negative?
Maximum.
Correct.
Maximum.
And what about this?
Minimum.
Minima,
Minimum.
right? Okay.
yes, sir.
Okay. So is there something else also I can infer about the properties of this curve? Yes, I can. This is 0, this is 2. This is a maxima. So before this, it was increasing only. After it, 2 came minima, ऊपर चला गया. Again, it is coming out like this. Okay? ठीक है ना? Okay.
Yes, sir.
Yeah? Yeah. Do you have something to ask?
No, sir.
Okay, great. Okay. समझ आया ना सबको? कैसे किया? See, the thing is, it is entirely upon you. Okay. I am giving you a function. It is entirely upon you. It is entirely upon you to check if you need to use the first derivative rule or the second derivative rule. Okay. First derivative rule means find critical points. Then check if it is plus minus plus plus something like that. Okay. Around it, how are the values behaving? Or find the critical points. Then differentiate it once again, and then put the values of these critical points. If it is negative, positive, or equal to 0, you directly have your answer. Okay. Both of these are equally good. Just like it is your call, depending on how long the function is, how complex the function is. Okay. Do you guys have the NCRT book? NCRT book है तुम्हारे पास?
No, sir.
Okay, like which book do you follow? What is your curriculum? You are, I guess, from state board, right?
Yes, sir.
Okay,
Yes.
okay, state syllabus. Okay, so like, uh, okay, so like NCRT book is available online also. I guess you can download it from online also, or I will ask ma'am. She will provide it to you. Okay, okay, great. So actually, the point is this maxima, minima, all that. So we have completed successfully class 11, limits and derivatives. Okay, this is all syllabus we have. Okay, ठीक है. तो क्लास 11th में बस इतना ही, मैक्सिमा मिनिमा निकाल लिया ये सब. दैट्स इट. ओके, एंड दिस इज ऑल यू विल एवर नीड इन फिजिक्स. Yes, yes, Manoj, yes, 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 I will. Now I am here for that only. आज जो पढ़ाना था वो हो गया, पढ़ाने का पार्ट हो चुका है. सेकंड डेरिवेटिव टेस्ट करवा दिया, फर्स्ट डेरिवेटिव टेस्ट करवा दिया, दोबारा ऊपर से नीचे दिखा दूंगा. You will receive this PDF also in just 10 or 15 minutes after the class is over. So first I taught you what this slope means. If slope is positive, it means the function is increasing. If it is negative, it means it is decreasing. Okay. At the point where dy by dx is 0, it is called critical point. Then we found out the 4 types of critical points: plus, 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 minus, minus, plus, and minus, minus. Okay. Minima, maxima, faltu points, useless, point of inflections. Then we calculated this. Then we used the second derivative test. Second derivative test says that you first calculate what are the critical points, then you find its minima, maxima, inflection. Okay. Okay. So yeah, that's it. And we have completed 11th class that topic. So yeah, Manoj, which question do you want me to do currently? And Gayatri, we will discuss homework problems after I have cleared his doubt. Okay. So yeah, Manoj, कौन सा problem? Which problem do you want me to explain?
2x square plus
3x plus 9 वाला, ये कौन सा problem था? 2x square plus
9 सर
3x.
नया वाला,
कौन सा?
नया वाला सर.
Means you want, अच्छा, you are giving the question.
मैंने
Okay.
क्रिएट किया.
हाँ, okay. So what is the problem?
2x
2x
square
square
plus
plus 3x plus.
3x plus 9.
Okay. So dy by dx बता दो यार इसका जल्दी से. It will be
4x
4
plus,
4x plus 3, right?
yes sir.
4x plus 3 हो जाएगा. Critical point बता दो इसका.
माइनस में आ रहा है.
Minus 3 by 4, right?
माइनस ले सकते हैं क्या सर?
Sorry?
Can we take minus sir?
Yes, this is just the critical point. It is just telling you the value of x, where like it has nothing to do with being positive or negative. It is just showing you कि ये जब मैं function plot करूंगा, when I will plot this function, something special will occur at this point.
Okay sir.
It has nothing to do if x is positive, x is negative, x is 0. Critical point can be anything. Critical point is just telling me कि जब मैं इसका कर्व ऐसे प्लॉट करूंगा, तो at this particular value of x, something special will happen in the function. Okay.
Okay sir.
Okay. It has got nothing to do with being positive, negative, or anything. Okay. Okay. हाँ, तो फिर कल के प्रैक्टिस प्रॉब्लम से डिस्कस करते हैं. गायत्री, डू यू हैव एनी डाउट इन टुडे? आश्रिता, व्हाट अबाउट यू? आया सब कुछ समझ में या कुछ भी नहीं आया?
Yes, sir.
आया, समझ आया?
Yes, sir. Understood.
ठीक है, चलो. ओके. या गायत्री, बताओ. You will tell me now what were your doubts. Yeah, I actually saw your homework. Just give me 1 minute. I'll get my phone. हाँ, हेलो.
Yes, sir.
हाँ, आवाज आ रही है ना? Audible?
Yes, sir.
Hmm. So yeah, I did see that. Ma'am had sent me that. Just a minute. You have solved only 7 problems I've seen.
Yes, sir.
You couldn't do the others, I see. Okay.
I
No,
didn't
no.
wrote them, sir.
Okay, no problem. I'll just have a look at it. Okay. Yes, please give me 2 minutes to solve her doubt. Yeah, so see, the first problem that you have done, you have done only 7, right?
Yes.
Okay, so 7, the first one is done correctly. The second one is done correctly. You have written it something like this, okay? So its derivative will be first approach from outermost side, so it will be cos of x square plus 5x plus 6. This is correct. Multiplied by. So you have written it like this. So actually, I just wanted to tell you it will be this. Okay. Everything is getting multiplied. So it will not be, you have left the brackets open over here.
Okay, sir.
So it will be 2x plus 5. Okay. The third question is also correct. Yes, it is correct. Uh, fourth one is wrong. Fourth one is wrong. Fifth is also wrong. Sixth and seventh are also wrong. Okay. So which one do you want me to explain right now? See, you need to see one thing I have recognized about every one of you. कल कल जो मैंने पढ़ाया था ना, if I give something like this, everyone will do correctly. But if I give something like this, everyone will do it in the wrong way. So that means everyone has understood partially correct. See, जिसने भी इस टाइप के प्रॉब्लम सॉल्व किया है ना, उसने सबने सही किया है, लेकिन जिसने भी इस टाइप के किया वो सब गलत हो रहे हैं. Every problem that is in this format is the answer is coming in the wrong way. Okay, so I will just explain to you. So if y is equal to sine to the power 7x, okay, so it is x power 7 बाहर है, उसके अंदर मैंने डाला हुआ है sin x, right? Right?
Yes, sir.
x पावर 7 का डेरिवेटिव क्या होता है? x पावर 7 का डेरिवेटिव क्या होता है? Don't worry.
7x power 6, sir.
Yes, correct. So it is 7x power 6. I am telling you approach from the outermost side. But the point is, instead of x, we have put sin x. So it will be sin x to the power 6. After I have completed this, I will move inside. I encounter sin x. Sin x का हो जाएगा cos x. Have I substituted anything inside sin x? No. So I'll just leave it as it is. Okay. Okay. So I'll just I will just do it one more. If I do it something like sine raised to 7 of x cube, so it is x raised to 7, उसके अंदर मैंने sin x डाला है, उसके अंदर मैंने x cube डाला. Okay, so basically what it is कि x raised to 7 के अंदर मैंने sin of x cube डाला है. Okay, so what is that? I will approach from outermost side. What is derivative of x raised to 7? Tell me, what is it?
6.
Yes, correct. 7 something to the power 6. What have I substituted in place of x?
Sine.
In sine of, yes, tell me, sine of what have I substituted in place of x?
Sine of x.
No, that is the mistake you are making. Yes, exactly. See, x raised to 7 के अंदर मैंने sin of x cube डाला है, sin of x नहीं डाला है, so it will be sin of x cube multiplied by, okay, multiplied by, we will just move ahead. Okay, okay, so ठीक है, अब मैंने outermost चीज को खत्म कर दिया. Now I encounter sine. What is the derivative of sine?
Cos.
ओके कॉस ग्रेट, लेकिन कॉस के अंदर मैंने क्या डाला हुआ है, सॉरी मतलब एक्स की जगह मैंने क्या डाला हुआ है, व्हाट हैव आई पुट इनसाइड इट?
X cube.
Yes, x cube. Okay, I closed this, I moved inside. What did I encounter?
3x
X
square.
cube. Great, great. Because I haven't put anything inside it, so I will just end it over here. This is the final answer. Okay,
Okay, sir.
okay. So I'll just tell the answer to one question and then you will need to solve it again. Okay,
Okay, sir.
okay. So it is, see, you have solved this question actually correctly only. I don't know why you are making mistake everywhere else. Minus cos of tan of x raised to the power. Okay, okay, I got it, I got it. ऐसे क्वेश्चन तो तुम सब सही कर रहे हो. You are doing such types of problem, you are doing correctly only. The problem is where sine is having a power or cos is having a power. Okay. So first we will make this small flow chart. x square है, उसके अंदर तुमने डाला है cos of 3x cube plus 5. ठीक है, x square के तो अंदर तुमने ये डाला है. अब इस चीज को मैं और बाइफरकेट करके लिखूं तो मैं ऐसे लिख सकता हूँ cos of x के अंदर तुमने डाला है 3x cube plus 5, right? So I will approach from outermost side. Last problem to be solved. Please 2 minutes. So x square का डेरिवेटिव क्या होता है?
2x.
2x, लेकिन x की जगह मैंने क्या डाला हुआ है? What have I put in instead of x?
Cos 3x cube plus 5.
Exactly, correct. This is correct. Okay, so I have ended this part. I came here. I came here. So the next function I encounter is cos. What is the derivative of cos?
Minus sine.
Minus sine, correct. But x की जगह मैंने x नहीं डाला है ना अंदर. Instead of x I have put, what have I put instead of this x?
3x cube plus 5.
Exactly. Multiplied by. I ended this part, I moved inside. What is the derivative of this thing?
9x square.
Plus 0 only. So
Yes.
I can directly write 9x square. So this is the final answer. 2 cos 3x cube plus 5 into minus sine 3x cube plus 5 into 9x square. Fine?
Yes, sir.
Okay,
Sir,
I hope you will. Yes, yes. Sorry?
can you explain sixth one?
Sixth one. Okay, sure. Sixth one. Can you please tell me the question? Is it this one? X raised to 10 divided by sine of x raised to 6.
Yes, sir.
Okay. So see, earlier I had taught you about the division rule, right? Division rule.
Yes, sir.
So it is a combination of division as well as chain rule. So first tell me what will be y1 dash? It will be 10x raised to the power 9. What will be y2 dash? Tell me, इसका डेरिवेटिव क्या होगा? ये तो बहुत इजी है यार. Tell me. Cos of? Tell me.
6x to the power 5.
No. That is the error you are making again. See, sine of x to the power 6. Approach from outermost side. It is cos. And when you are approaching from outermost side, keep all the inside things as it is and just copy it over here.
Okay, sir.
And when you have completed the outer, move inside and now differentiate it. What the mistake you have made in all the questions is you have simultaneously तुमने simultaneously दोनों को differentiate किया है. The way you are doing here, what you did is cos and then inside you went and differentiated this also. No, it is wrong. जब तुम अंदर जा रहे हो, when you are moving inside, when you are looking at the outermost function, whatever is inside that function will come over here as it is. Okay?
Okay, sir.
Okay. Okay, so yeah, so See, you came till here, right? y1 और y2 का हमने डेरिवेटिव निकाल लिया, ठीक है?
Yes.
So you know what will happen if we have two functions in division? It is ऊपर वाले का डेरिवेटिव इंटू नीचे वाला माइनस नीचे वाले का डेरिवेटिव इंटू ऊपर वाला होल बाय नीचे वाले का स्क्वायर. Okay. So yeah, so that's it for today. Actually, I can't continue further. I am okay. So yeah, please practice your problems and please practice NCRT. That's it. Sir, that's it. Ma'am, that's it for today. Okay. I'm ending the class. Please practice.
I have a little announcement to make. Okay, children. So, hi, I'm Alekhya. Hi, I'm Alekhya. So, we have another scholarship. So that the exam for that is to be conducted on 14th of July, sorry. 14th of this month. So tell to everyone, to your friends, to your relatives, to your classmates. So exam is on 14th of this month. It will be online. So they can apply for the scholarship through the link we'll give. And this time we'll select 80 students. So say this to your friends, relatives, and classmates. Yes, sir, we can end the session. I'm ending the session.